Hello and welcome back to my channel. Today we are going to discuss the next two questions from specimen paper for the examination from 2020, and it is paper 6, means probability and statistics 2. So here's the question number 4. The lifetimes in hours of long-lived light bulbs and low light bulbs have the independent distribution and normal 10, 20 and 45 square, means mean and variance are given. Again, for the another one, mean and variance are given. So first part is to find the probability that the total of lifetimes of 5 randomly chosen long-lived bulbs is less than 5200 hours. So we are taking the 5 observations, means we can take it as L1, L2, L3, L4, L5. So if we take this as a random variable, we need this parameter would be 5 times 10, 20 and 5 times 45 square. We are not going to multiply with 5 square here because it's a 5 observation. We are not multiplying by 5. It is 5 observation, or we can calculate it. It is equivalent to 5 into 120. 1020 is 5100. And this 5 into 45 square is 2025 into this, so it become 10,125. So now once we have this parameter, we can get this question easily, like, because this question become, we have this long-lived bulbs total is less than 5200 hours, so it is x less than 5200, and which can be written with the help of standardized normal distribution z less than 5200 minus the mean, here mean is 5100, over standard deviation. This is variance, so standard deviation is the square root of this. And now we will calculate this. We have this value as 0.993438, so we can write it as 0.994, because in the distribution table we can get only till 3 decimal places value, so we will take it as 0.994. so let's get this value from distribution table. So here's the normal distribution table. We had the value 0.994, so first one 0.9, it is here, and then 9 is here, and the last one is 4, which is here. So 0.99 corresponding to that we got 0.8389, and corresponding to 4 we got 10. So we can add it, so the last answer would be 0.8389 plus 10 is going to be 99. And if you write the answer till 3 significant figure, this can be written as 0.84. It would be 84, because till 3 significant figure it is 9 and the next one is 9, so it would be 0.840. so we'll write it there. So this value is 0.839 plus 399, so plus it, because till 3 significant figure it is 0.840, and that's the probability. I hope it is clear. Let's discuss the B part of it. Here's the B part. Find the probability that the lifetime of a randomly chosen inner low bulb is at least 3 times that of a randomly chosen long-lived bulb. We are choosing a random observation, only one, so it means if we take inner low bulb as random variable as E and long-lived as L, so they want the probability for E to be at least 3, means greater than or equals 3 times of this. So we will make a random variable here by taking 3L one side, so it become E minus 3L. So it is the combination of normal distribution, so it would be again normal with the mean and variance changed this time, because the new mean mu and variance sigma square would be, earlier E was, from the first part, E was normally distributed with mean 1020 and variance 45 square, and it is long live, and inner low was again normally distributed with 2800 as the mean and 52 square as the variance. So the new mean would be E minus 3L, that is 2800 minus 3 times that of long live, that is 1020, and variance would be, new variance sigma square is going to be variance of E, that is 52 square, minus 3 times L means it is going to be plus 9, 3 square is 9, multiplied by the variance of L, that is 45 square. So we will calculate these values, and these values are minus 260 and here it is 20,929. So now our question become, if we take E minus 3L, so it become finding the probability of, now we are taking it as X, so it is going to be easy to write. X is greater than 0 or greater than or equals to 0. It is not going to make any difference because we are doing the continuous distribution. So in continuous distribution, even a single value will not make any difference. So it is going to be same as probability of X greater than 0. So we'll convert it in the standard normal distribution, that is Z greater than 0 minus mean, and minus mean is 260, minus 260, so it becomes plus 260 over the square root of variance, that is standard deviation, so it is 2929. Now we will calculate this, 260 over square root of this, and this value is coming probability of Z greater than 1.7972, so it is 797. Now we will see the graph, distribution graph. This 1.797 would be right side of the mean, and if we require this value, because it is greater than this value, so we require this area, that is the probability, so it would be 1 minus this area, this area, so it is going to be 1 minus 5 of 1.797. So let's calculate this value from distribution table. So 1.7 first of all, so 1.7 is this, and then 9 is here, and then again 7, so it is this. So corresponding to 1.79 we have this value, and the next 7 we have 6, so altogether it is going to be 0.9633, so it is plus 0.0006, so it becomes 0.9639. 0.9639. It was 33, but we have added 6, so it becomes 0.3639. Now we will subtract this value, and this value is coming, this is a probability 0.0361, and that's the probability. I hope it is clear. Let's discuss the next question now. And here's the question number 5th. The diagram shows the graph of probability density function f. This is PDF of a random variable x, where fx is defined as this, that in between 0 to 3, this is 2 over 9 3x minus x square, a quadratic curve, and otherwise like everywhere else it is 0. So we can see the graph. Since the question is to just to just to state the value of expectation of x, so we can see from here that this graph, this quadratic curve is symmetric. So it is symmetric about this minimum point, we can see maximum point, we can see that it is going to be here. So we can directly say that expectation is this, and this value is 1.5 because it is going to lie between 1 and 2. So expectation, we can directly say it is 1.5. Otherwise also we can find this by the formula. Expectation of x is minus infinity to infinity x fx dx. So from that also we will get the same answer. Otherwise, if it is given just to state it and we can see this is symmetric about a line, then we can directly put that value, and it is 1.5 here. Now we need to find variance of x. So variance of x is expectation of x square minus square of expectation of x. So we will calculate this now. And expectation of x square means here when it was expectation of x, it is x times fx. Otherwise it is going to be x square times fx in this case. And since it is from minus infinity to 0 0 and 3 to onwards till infinity it is 0, so we will write this integration as 0 to 3 x square times fx, and fx is 2 over 9 3x minus x square dx, and minus expectation of x is 1.5, so we can calculate, we can directly write it there 1.5 square. So let's calculate this value separately. So if we simplify, we will get it as 2 over 9, and x square multiplied inside we got 3x cube minus x square into x square x power 4, and its integration would be, its integration with respect to x is going to be 2 over 9 outside and 3 by 4 x to the power 4 minus x to the power 5 over 5, and the lower limit is 0, upper limit is 3, so we will replace that as well. So it is 2 over 9 times 3 by 4 times x power 4, that is 3 power 4 81 minus x power 5 3 power 4 3 power 5 is 243 over 5, and minus lower limit is 0 anyway. So this value is going to be, we will multiply, you can see 9 times here, and if we multiply here 9, that is 27. So it become 3 by 2 into 9 minus 2 by 5 into 27. And now we have already calculated. We could have done this down there, but it's on the same screen, that's why I have written it here. And this value is coming 2.7, so we'll substitute here. It is 2.7 minus 1.5 square, so the total value is 0.45, and that's the variance of x. Because this is a method thing, so they will give the marks for method work. Let's do the next question now. And here's the next part, B part. State the value of probability between 1.5 and 4, including 1.5 and 4. So let me bring the diagram here, it would be clear. Yes, so from here we can see, as we have seen in the first part, 1.5 is the expectation, this average. So 1.5 is here, which balances this PDF. So we can directly state that this is going to be half of the probability and this is going to be half of the probability, and total probability is 1. So we can directly say that it is going to be half, that is 0.5. This probability is 0.5, because if we break it also, 1.5 to 3 it is half, but afterward till 4, 3 to 4, it is already, there is area under the curve is 0, so we can say that it is 0 0.5 directly. So 1.5 to 3, the probability is 0 0.5. And here's the next one. Find, given that probability of probability of x between 1 and 2 is 13 over 27, we need to find the probability of x greater than 2. So probability of x greater than 2, we can write it as 1 minus probability of x less than or equals to 2. And this probability we can write it as 1 minus, we'll break into two parts. One is, if we can calculate the probability from 0 to it is minus infinity, because it's a PDF, so we can say that the probability from minus infinity to 0, including 0, and then this is probability of x 0 to 2. That is what it means. X is less than or equals to 0 2. It's not required to write this because we can see that this is 0 any which way before below 0, but that's fine because it is, we'll write this as 0, we can see. So we need to find the probability of x between 0 and 2. The probability given is 1 to 2, so we will break it again. 1 minus finding the probability from 0 to 1, and then it is finding the probability from 1 to 2. So this value is already given, so it would be helpful. Otherwise this probability we can calculate from the function, because this PDF was given as fx as 2 by 9 3x minus x square between 0 to 3. So it is going to be 1 minus integration of this, we have seen it was 2 by 9 into 3 by 2 x square minus x cube over 3 between 0 to 3. It is 2 by 9, 2 by 3, 3 by 2 into 3 x square upper limit 9, 9 3 is 27 over 2 minus 3 3 is 9 3 is 27 over 3, and lower limit is 0, so you will get 0. So it is 2 by 9 times 27 over 6 if you simplify. So 2 3s are and 9 3s are 27, so it is sorry, we only need to calculate till, not all, we are calculating 0 to 1, so upper limit would be 1, not 3. So if it is 1, then it is more easier now, because it is 2 by 9 times 3 by 2 minus 1 by 3. So 3 3 is 9 minus 2, 7, 7 over 6. So 2 by 9, 2 by 9 into 7 by 6 plus the given value 13 over 27. So we got this value as 1 minus 9, we require 27, so we can cancel this. 3 9 3 is 27, so 1 minus denominator is 27, 13 20, it becomes 20 over 27, that is 7 over 27, and that's the probability. Now it was not required to do these calculation. We have I told you just to in case if you don't know how to work on it. Otherwise also we can see that this is 0 to 1.5, it is complete one, and if we 0.0 to 1.5 is the half, and if you take 1 to 2, 1 to 2, then the remaining probability means this area, if you take this area and this area, they are going to be same. So if we subtract the total area, means 1 minus 13 over 27, we will get the area which we have I have shaded in yellow. So this part, and since we require only this reason, so we can take this upon 2, because earlier it was the sum of these two. If I divide it by 2, this is going to be the answer. So in that case also we would have got the same answer, but that's fine. So that's it for this video. I hope it is clear. Let's meet again in the next video for the last two questions. Till then, thank you so much.